Hi, I'm Matt with Spearhead Robotics, and today we're going to learn about voltage dividers or series resistors. So imagine you had a 5-volt battery, 5 volts coming out one terminal and 0 coming out the other, and we had a wire connected to each, and these were disconnected at the top. Now, the electrons can't jump from one to the other. So one of the wires, the one attached to the 5-volt terminal, has 5 volts, while the one on the other side has 0. So now let's introduce a rod of uniform resistance. The wire on one side still has 5 volts on it, and the wire on the other still has 0. They're still connected to the same terminal of the battery. But that means that across this resistor, there is 5 volts of a voltage drop, and it's spread uniformly across the total resistance. A good way to show this is through an experiment. In this experiment, we're going to create a voltage divider. Now you can create a voltage divider out of any resistive material. I happen to have a paper towel handy, so I wet in this paper towel and we're going to hook up the positive and negative leads of a power supply to it, and we're going to run 12 volts through it. Now, if you remember from our previous discussion, the voltage drop across this entire thing is equal to the voltage being inputted in. So 12 volts is going to it, so 12 volts would be the voltage drop from this point to this point. Now we're going to use that to power an LED. So LEDs can only accept current one way. The anode is the longer end, the cathode is the shorter end, and the cathode always goes to your negative or ground. So we're going to attach that. I'm going to bend it so they stay a little bit apart. And that's going to go to our ground over here, where our 0 volts would be. Our anode is going to be attached to the longer end, and that's going to be able to slide anywhere along this rod of resistance. So we're going to place it all the way on this end, and that supplies it with the full 12 volts of power, because the voltage drop from this lead to the green lead is 12 volts. Alternatively, if we place it very close to the green lead, we're going to have the LED turn off, because that's about a 0 volt voltage drop across those. Now as I slide this farther away from the green lead, you'll notice that the LED gets progressively brighter as a progressively larger voltage drop powers it. If we place it halfway in between, half of the voltage drop will be expressed in the LED. Same with any point along this. Now if we go back to our circuit example with the uniform rod, and we're going to replace this resistive rod with 2 resistors of equal value, let's say 5 ohms each. And we are going to place an LED across one of the leads. So that means that 5 out of the 10 ohms, or 1/2 of the total voltage drop, goes to the LED, so 2.5 volts of voltage drop. Now we can express this mathematically through Ohm's law, with voltage is equal to the current times resistance. And we know the voltage is equal to 5 volts. We have a 5-volt battery. And we equate that to the unknown current times the resistance, which is 10 ohms around the loop. That gets us that the current is equal to 1/2 of an amp. So if we then take that and we want to find the voltage drop across the resistor, we know that the current is the same at every point in the loop. The electron flow is the same on one side that it is the other. The voltage drop is equal to the current through that resistor, which is 0.5 amps, times the resistance of the resistor, 5 ohms. That gets us that the voltage drop across that resistor is 2.5 volts, just how we intuitively thought it would be. A practical usage of voltage dividers is when one of the resistors can change in resistance. In this example, we're going to use a thermistor. A thermistor, or thermal resistor, changes its resistance based on the heat applied to it. So the first resistor in our circuit we're going to replace with a fixed 1 ohm resistor. And we're going to place the thermistor in for the other. And this thermistor is going to be able to range from 1 ohm when it's cold to 4 ohms when it's hot. Now if we cool down our circuit, the thermistor expresses 1 ohm resistance, and 1 divided by 2 would give us half of the resistance value. So the LED would shine half bright with 2.5 volts flowing through it. Now if we were to heat the circuit up, the thermistor would express 4 ohms of resistance, and 4/5 of the total voltage drop would be applied to the LED, increasing its brightness. Now let's do an example of that on the breadboard. To make this circuit, we're going to need a breadboard, 2 jumper wires, a 47k ohm resistor, an LED, a thermistor, and a piece of ice. So we are going to first make the voltage division part, and that's going to be attaching one of these resistors in series with our thermistor, which remember is also a resistor, just a variable. We're going to place that there and make contact. Now we're going to place our power leads on this side and this side, so that when, I'm going to turn this around, so that when power flows through it, it will flow through both resistors in a series format. Now I'm going to add the LED, and remember you need to attach the LED cathode, the shorter side, to where you're grounding from, or the negative terminal. And this yellow is going to be our negative, so we're going to attach that like so, to where it is dependent upon the resistance of this thermistor here. Now we are going to attach the leads, which will create a voltage for it. And we're going to touch the thermistor with the chunk of ice, and then take it away and watch it dim. And this is creating a voltage divider out of a variable resistor, a thermistor, and a fixed resistor.